Welcome friends, let us continue to study about the refrigeration and air conditioning on my YouTube channel. Kindly like, share and subscribe my YouTube channel. In today's lecture, we are going to study about the heat engine, refrigeration and heat pump. In the previous lecture, we have studied that transfer of heat is possible from low temperature to high temperature unless or if we provide the external work done. And external work done in case of refrigeration and air conditioning is nothing but the electrical energy that we supply. Now let us study the fundamental of heat engine, refrigeration and heat pump. See, we have studied the heat engine. Now in heat engine, what are the different components? So heat source is one of the component, heat sink is one of the component, and the system. So heat is transferred from heat source to the system, that is QS. The system, that is the heat engine system, converts that heat into the work done, and the remaining heat is rejected to the heat sink. And in that case, efficiency of the heat engine, that is equals to work done upon heat supply. So that we have studied during the heat engine. Now the refrigeration. So in the refrigeration also the same components are there, that is the heat source, system and heat sink. But here heat from the heat sink, that is the low temperature, is supplied to the system, and that is known, and the heat from the system is now supplied to the heat source, and that is not possible unless until we supply the work done from the external side. So if we don't supply work done to the system, then it is not possible that heat from the heat sink will be supplied to the system and then the heat will be supplied to the heat source. It means heat cannot be taken from the room, which is at generally as from our example 35 degrees centigrade temperature, and then heat cannot be given out to the atmosphere, which is at 40 degrees Celsius temperature, if we don't supply the work done. That is, if we don't supply the electric work. It means if we don't switch on the AC. Now heat supply to the system, it is denoted by the system QS, and in the refrigeration term, in the refrigeration technology term, it is known as the refrigerating effect, and it is denoted by the symbol capital N. So whatever the heat is removed from the room or from the low temperature, it is denoted by the symbol QS or capital N, and it is denoted as the refrigerating effect. Then heat is rejected to atmosphere, that is a high temperature heat source, and that is denoted by the symbol QR. Now here what is important? Are we focusing on what is the temperature of heat source or what is the temperature of outside atmosphere, whether it is 41, 42, 43? No. What we are focusing? We are focusing on the temperature of heat sink, that is the room temperature. Whether it is 35, whether it is 34, whether it is 25, whether it is 20, whether it has reached to the set temperature or not. It means we are focusing on heat sink. And what we are focusing? How much heat is removed from the heat sink, that is room or compartment, that is important for us. And so we are focusing on the heat sink only. And in that case, this system is known as the refrigeration system. And the efficiency of that refrigeration system is measured in terms of the COP, that is the coefficient of performance. So the coefficient of performance for the refrigeration system, that is equals to heat supply upon work done, or it is the refrigerating effect upon work done. So you can see it is exactly opposite to the heat engine efficiency, which is written here. So the efficiency of the heat engine equation was work done upon heat supply. But in the refrigeration COP, that is the coefficient of performance, equation is opposite to the heat engine equation, that is the heat supply upon work done, or ultimately refrigerating effect upon work done, that is QS by W or it is N by W. QS by W upon N by W. Next one is the heat pump. Now heat pump and refrigeration are same. Only here we are focusing on the heat source, and heat pump is utilized in a, you can say, a room heater like that. It means if you want to heat the room during winter season. So what is important for us? What is the temperature inside the room? That is important for us. And so here we can say how much heat is added to the heat source, that is room or compartment, is important. And in that case, COP equation is QR by work done, that is the heat rejected to atmosphere or the room ultimately divided by work done. Now let us study the difference between the heat engine and the refrigeration. Heat engine works on different cycles as we have studied. And what were the cycles? Carnot cycle, Rankine cycle and Otto cycle. And that cycles may have different working substance, working fluid, that is air, steam, etc. We know that Carnot cycle having air as a working medium. Similarly, Carnot cycle, it is having vapor or the steam as a working medium. Similarly, Rankine cycle as a steam or a vapor as a working medium. Otto cycle, air as a working medium. So, cycles may have different working substance or working medium. Refrigeration or heat pump. Again, refrigeration or heat pump also works on different cycles. Here it cannot be the Carnot or Rankine cycle. Here the cycle names are VCRS, that is a vapor compression refrigeration cycle or system, vapor absorption refrigeration system. So these are the cycles on which the refrigeration or heat pump works. And it also requires the working substance. Working substance or working fluid is known as the refrigerant. So to work on different cycles for the refrigeration or heat pump, we require some working medium, as in case of heat engine also. And that working medium is known as the refrigerant. If I will say refrigerant, it is nothing but the working medium utilized in the refrigeration. And the examples are R134A, R22, etc. So refrigerants. What is a refrigerant? So it is a working medium used in refrigeration and air conditioning system. So you can see here there are different types of refrigerants that is being invented. Previously we were using the NH3CO2. Then after second generation refrigerant, hydrocarbon, NH3 ammonia, H2O water. Then CFC, chlorofluorocarbon, NH3 H2O. Then after HFC, HCFC, CO2, HFC, HFO, and again the research is going on. Why research is going on? So that the refrigerant are not, you can say, damage to the atmosphere and environment. So refrigerant is nothing but the working medium utilized in the refrigeration and air conditioning system. So this is, you can say, the animation for the vapor compression refrigeration cycle that we are going to study in deep in a later on. But whatever the working medium is passing through the tube, that working medium is known as the refrigerant. It can pass through the compressor, then tubes, and these tubes are known as the condenser tube. Then it passes through the tube known as the expansion valve. Then it passes through the tubes known as the evaporator, and then again back to the compressor. Kindly ask your queries in the comment box of the video. Kindly like, share and subscribe my YouTube channel. Thank you.